Good afternoon. Today we'll see the topic rheology. It comes under fermentation technology of MSc Microbiology 2 syllabus. So the word rheology comes from the word rheo, which means flow, and logy is study. So rheology is the science that concerns with flow of liquids or deformation of solids. For this PPT, we'll stick to the flow of liquids. Many times when we hear the word liquids, there are two terms that come up. The terms are viscosity and fluidity. So if you see a fluid, it does not move as whole, but rather it moves as layers. So if you can just see my pointer here, you can see this whole thing is a liquid which is divided into multiple layers. So as the top layer moves, after the topmost layer moves, the layer beneath that will move. Okay, so because these two layers are moving, there is going to be some amount of internal friction. If this friction between those two layers is less, the fluid can flow easily, and this property of the fluid to flow easily is called as fluidity. Okay, but what happens when there is internal friction between these layers? So when there is internal friction between these layers, there the fluid will show resistance to that movement, and this resistance is nothing but viscosity. Okay, my PPT has just got hanged. I think my net is not working properly. Can you hear me? Hello? Hello?
Yes, we can hear you.
Okay, but my mouse has got hanged. Sorry, technical error. Okay, that's it. So viscosity is the resistance to change in shape or movement. It is because of internal friction. If you can see here down, my mouse is not working, so just excuse me for that. So now if you see here, water, there is very little internal friction between the layers. Okay, so it's high in fluidity. So if you can see, water is highly fluid. Whereas if you see oil drop or say honey, in that case, there is a lot of internal friction between the layers. And so it is said to be highly viscous. Why to study rheology? What is the significance? So many a times when you're formulating drugs, you need to know the consistency of that particular liquid. Some injections, if you see, they hurt a lot when you take in the injection. That is because they're highly viscous. So in drug formulations or in fermentation technologies, when you are making wine or broth, rheology comes into picture. Based on this property, the viscosity properties, the fluids are divided into two types. One is Newtonian fluids and the other ones are non-Newtonian. So why the name Newtonian fluids? So Newtonian fluids, they obey Newton's law of viscosity. So Isaac Newton was the first person who derived the equation between shear stress and shear rate. So according to him, okay, so if you just look at this diagram over here, you'll see two terms, shear stress and shear rate. So what is shear stress? The word stress itself means some kind of pressure or force. So it is the force that is applied to liquids. Whereas in case of shear rate, if you look at the word rate, it says it has something to do with speed, right? Speed means movement. So when you talk about shear rate, it is a movement that is caused. So whenever you apply a force to the liquid, that force is known as shear stress, and the movement that is caused in the liquids is nothing but shear rate. So if you look at Newtonian fluids, according to Newton's law, here it says that shear rate is proportional to shear stress. That is, they have a linear relationship. As shear stress increases, shear rate will also increase. That is, as you apply force, the liquid will move, giving it a constant viscosity. So shear stress and shear rate are proportional to each other in case of Newtonian fluids. Some examples of Newtonian fluids are water, benzene, glycerol, and ethyl alcohol. What I would suggest is that you go online and look out for more Newtonian fluids. So now what are non-Newtonian fluids? Obviously, it's opposite to the Newtonian fluids. So here in this case, the shear stress will not be proportional to shear rate. They are not going to have a linear relationship. Let's look at these two videos. So here if you see in this video, that's egg. So egg right now is very viscous, but when I'm applying force to it, when I'm beating the egg, shear stress is being applied, and that shear stress will give rise to a lot of shear rate. Okay, and then viscosity of this particular omelette is going to decrease. That means it's going to become more fluid in nature. So this is called as shear thinning. So what is shear thinning? Shear thinning is when the viscosity decreases under shear stress. Now let's look at this one. Obviously, this is the Dalgano coffee. I don't know if I'm pronouncing it right, but if you see, initially, when you mix coffee with water, it's highly liquid, right? So viscosity is very less. But as in when we are beating up the coffee, it starts to thicken, and that is nothing but uh, its viscosity being increased. So here in case of shear thickening, viscosity increases under shear stress. So if you see in both case of omelette as well as in case of coffee, the viscosity is not remaining constant. Either it is going into the shear thinning part, whereas the viscosity is decreasing, or it is going into shear thickening part where viscosity is increasing. So in both these cases, these fluids are not obeying Newton's law of viscosity. So these fluids are called as non-Newtonian fluids. This is a graph showing relationship between Newtonian fluids, shear stress and shear rate. So the first type of non-Newtonian fluid we'll see is Bingham plastic. If you can look at this graph, this line represents the shear stress. Stress again, that means how much force we are applying to the liquid. And here on the x-axis, there is shear rate. That is the movement that is caused. If you can see, there is no movement in the Bingham plastic till you reach this point. That means I'm going on applying stress over here. There is a lot of force being applied, but the liquid is not moving at all. There is no shear rate seen till you reach this point. This point where the liquid now will start to flow is called as the yield stress. So yield stress is the minimum stress that is required for a liquid to show movement, for shear rate to happen. After that, if you see, it is following the Newtonian fluids. So in the beginning, no matter how much shear stress you apply, there is not going to be any shear rate. There is not going to be any movement until a yield stress is reached. When you reach a certain yield stress, then the liquid is going to exhibit Newtonian fluid. Such type of fluids are called as Bingham plastic. The other one now is pseudoplastic rheology. So if you look at this graph here, what is happening is initially when you're increasing shear stress, shear rate is increasing more. That means थोड़ा सा भी force लगाया तो movement ज़्यादा होगा. Right? That means you're not proportional. I am just going to apply a little force, but the movement is going to be considerable. That means the liquid is becoming more viscous if I apply stress to it. The viscosity here is, sorry, the liquid is becoming less viscous. Viscosity here is decreasing. It's becoming more fluid. Such type of liquids are called as pseudoplastic liquids. The other one is dilatant rheology. It's reverse of pseudoplastic. So if you see in dilatant, I'm applying considerable amount of stress, but the change in the movement, that is the shear rate, is very little. Okay, that means here, as I go on applying shear stress, the shear rate is not increasing in that much amount. The liquid is tending to be more and more viscous. So in this case, the viscosity of that particular liquid is increasing with shear stress. That is, shear thickening is taking place. Such type of liquids is known as dilatant liquid. The next one is the casein body. In case of casein body, if you can see the graph of casein body and the graph of pseudoplastic, they look the same. The only difference being, in case of casein body, there is a yield stress that is needed. Okay, that means initially there is not going to be any movement in the liquid till a yield stress is reached. Once you reach a minimum stress to cause movement in the liquid, that liquid is going to follow the property same as that of pseudoplastic. Okay, so just revision, this is Newtonian fluid wherein shear stress is directly proportional to shear rate. Bingham plastic, which shows Newtonian property but it needs a yield stress. The pseudoplastic, wherein the viscosity is decreasing as you increase the shear stress. Dilatant, where the viscosity is increasing when you increase the shear stress. And the last is casein body, which is same like pseudoplastic but it needs a yield stress. I hope you all have understood the topic clearly. In case there is any doubt, my email ID is on the screen. You all can ping me anytime. I wish you all the best.
Thank you.
Thank you, ma'am.